We're going to spend today and tomorrow looking at lesson 5.5. Lesson 5.5 is Law of Sines. And then we'll spend time later this week looking at lesson 5.6, which is Law of Cosines. Law of Sines and Law of Cosines do similar things. They allow us to find missing sides or angles in triangles, but just given different situations. So, the law of sines. We're going to definitely talk some geometry today, so hopefully you brought your geometry brain with you. In any triangle ABC, with angles A, B, and C, and opposite sides A, B, and C. So you'll note they usually use the capital letters for the angles, the points, the vertices, and the lowercase letters to represent the sides. Okay? And do notice, if here's angle A up top, where is side A? Side A is the one that is directly opposite it, right? If angle B is over here, side B is the one directly opposite. Angle C is here, side C is the one over there. Okay? So those are all the pieces. Now, if we have this triangle with these angles at sides, the following equation is true. The sine of angle A over side A is equal to the sine of angle B over side B, which is equal to the sine of angle C over side C. So this right here is your law of sines. Okay? Our law of sines can be broken up into pieces. So again, it's going to be based on what we know. We're always going to have to know at least 3 aspects of our triangle, depending on the situation. But basically, we can set up proportions. Okay? And obviously, this also has to do with, we're talking about not right triangles here. Okay? We have other things with right triangles that we can do, because we can just look at the sine or cosine of an angle, or we can use Pythagorean theorem. These are not right triangles. So, we can look at the fact sine A over A is proportional to sine B over B. Or we could just use sine A over A is proportional to sine C over C. So any pairs will work within the triangle. Remember the acronyms AAS, ASA, SAS, and SSS from geometry? You used them, right? That's something that still stands out in my geometry brain, and I've never taught geometry, so it's what I remember. So angle, angle, side, angle, side, angle, side, angle, side, and side, side, side. These apply to the law of sines and the law of cosines, which is the next lesson. And in addition to those, which were the ones that were allowed in geometry, we're also going to talk about angle, 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 and side, side, angle, okay, which we haven't used before. Today, we're specifically talking about law of sines. And so angle, angle, side, angle, and side, side, angle are the 3 we get to talk about. And so realize, if we're talking about angle, side, angle, you guys understand what that means, right? Angle, side, angle means given an angle, a side, and then the angle following it. So given 2 angles and the side in between it. Angle, angle, side would be given an angle, and the side that follows it. Okay? Side, side, angle would be given a side, an angle follows it. Those are the 3 options we're looking at. Each setup's a little bit different in terms of, how things work, but that's the basic gist. Let's look at example 1. Example 1, basically, we're working with solving triangles that have the angle, angle, side, and angle, side, angle setup. So basically given 2 angles. And with these 2 setups, if you're given 2 angles, you're always going to get a unique solution. So one solution, no tricks. Look at our example. Solve triangle ABC, given the angle A is 36 degrees, angle B is 48 degrees, and side A is 8. Now, first of all, what do they mean by solve? Do we know what it means to solve a triangle? Not necessarily, probably. But solve a triangle, our job is to find any missing sides and angles. Okay? That is our job here. So we are given angle A and angle B, and we are given side A. So we have 3 missing pieces that we want to look for. Now, let's talk real quick. Which setup is this? If they're giving us angle A, angle B, and side A. If you use this triangle up here, angle A, angle B, and side A. Which setup is that? What are they giving us? Are they giving us angle, angle, side, or angle, side, angle? You guys have to help me out here. Angle, angle, side. Angle, followed by side, right? So this is an example of an angle, angle, side setup. Now, I'm going to kind of write it out in that we already know, whoops, angle A is 36 degrees, yes? We already know angle B is 48 degrees. What do we still have to find in terms of angles? We have to find angle C. Just kind of trying to set up what all we have to find. We know that side A is 8, and we have to find side B and side C. Thoughts on where we can start?
Could you add 48 and 36 and subtract whatever that equals from 1?
Yeah. All 3 angles in a triangle always add up to be 180, yes? So angle A plus angle B plus angle C, that's given that equals 180 degrees, right? So yes, fill it in, do the math. So 36 degrees plus 48 degrees plus some angle C equals 180 degrees. So add those two, subtract them from 180, however you do your math. What do you get for angle C? I'll go with 96. And that's 96 degrees, correct? You got to throw in a radians there? Just to, hey, this is the good news about law of sines and cosines. We work in degrees. Because we don't talk about this triangle has, okay, this angle that's pi over 3, this angle is pi over 6, this angle is pi over 2. Thankfully, we don't do that because that'd be, oof. That's not my sense of fun. Okay. So now it is a matter of finding sides B and sides C. And this is where we use our law of sines. Now, with law of sines, we have to use, we're going to basically pick 2 of these fractions, set them equal to each other. And we have to use the given information. So in order, information that we're going to have to use, we're going to have to use this angle A information. Because we want a set of information, an angle and a side that go together. In order to set up angle sines, you have to have an angle and a side that you know both. So in this case, we know both of our A's, don't we? We can start by finding side B if we want. And so what I'm going to set up, and I'm going to write it out before I fill it in, is that the sine of angle A over side A is equal to the sine of angle B over side B. So I'm just setting the A's equal to the B's. Fill in what you know. Sine A is going to be sine of 36 degrees over side A, which is 8, equals sine B. Do we know sine B? Sine of 48 degrees over side B, which That's what I'm looking for, isn't it? So we are able to fill in a proportion where we know 3 of the 4 pieces in the proportion. Thoughts on how to solve? Basic algebra here. Don't go get fancy. If I have a fraction equal to a fraction, what's the easiest way to solve that? Yeah, I like to use cross products here. Okay, so if I use cross products, then I can say b times the sine of 36 degrees is equal to 8 times the sine of 48 degrees. How do I solve for b? How do I get b by itself? If it's b times the sine of 36, we're going to divide. And so b is going to be equivalent to whatever 8 times sine of 48 degrees divided by sine of 36 degrees is. And how do we finish this off? Or did you guys already do it? Gotta have the calculators working on this one, don't you? So I can type this in my calculator all at once. 8 sine 48 degrees over sine 36. You can do it with division symbol instead of the fraction bar. But does your answer match my answer? Yes? If it doesn't match my answer, those of you that aren't trying it right now, check your setting on the calculator, right? What setting do we need to be in? Degrees, yes? This whole lesson you should need to be in degrees. So just kind of be aware of that. Make sure your calculator is in degrees. Looks like for the most of this lesson I have 1 decimal place. To be honest, this one I actually have 2 decimal places, but if we just go 1 decimal place, this is approximately 10.1. Okay. We have found angle C. We have found side B. What do we still need to find? We need to find side C. So do you realize what we're going to be doing to find side C here? Basically redoing the problem we just did, right? Except this time, because we need to find side C, we have to use C's. And then technically you could use the A's or the B's with your C's. However, I have a definite recommendation here. When we did B's, we just rounded that B, that length of side B, didn't we? With that in mind, if you can avoid using a rounded number, I would. So when I set this up, I would suggest we use A's because neither of those values were rounded along with the C. Sometimes you have to use rounded values, but sometimes you can avoid it. Here we can avoid it. So I would set this up as the sine of angle A over side A equals the sine of angle C over side C. Now, if you use the B's, you should be very, very close, if not exactly the same. But with rounding, it could end up just a smidge different. I mean, I'm talking like a decimal place or 2 off. So not a lot, but that's my recommendation there. So set this up if you haven't already. Sine of 36 degrees over 8 is equal to sine of, what is it, 96? There it is. 96 degrees over C. Do you know how to solve this? This is why I said I like law of sines in most cases, because the math is pretty easy, isn't it? It's understanding how to set the problem up, which in this case was a pretty easy setup, and it's doing the math. So cross product says C times 36 degrees equals 8 times sine of 96 degrees. In order to solve for C, you, of course, divided. 8 times sine of 96 degrees divided by sine of 36 degrees. I encourage you to try the calculator at some point. I know it's easy stuff on the calculator, however, mistakes can also be made. 8 times sine of 96 divided by sine of 36. Right there, just kind of trying to demonstrate that, okay, I don't have to use a fraction bar, right? I'm just dividing by the sign of something, so I'm just dividing by one quantity. So approximate answer of 13.5. Okay. Questions here? We're all good? We got the basics? Law of sines isn't too bad, right? Okay. So this setup here was as long as we were given two angles. Given two angles, whether it be angle, angle, side, or angle, side, angle, you are always guaranteed to get one unique solution. Okay? And I mention that because we're getting ready to move into the ambiguous case. The bottom half of this page of notes talks about solving triangles, the ambiguous case, where depending on how you're provided, and here we're talking about side-side angle, so two sides and an angle not between those. As we talk about this, it all depends on the numbers. Depends on which side you're given is longer and whether your angle is acute or obtuse will determine whether you're going to get one possible solution, two possible solutions, or no possible solution. And we'll demonstrate each of those three options between this example and then examples B and C on the back, I believe. Yeah, we will demonstrate each of the possible examples or options. But the idea, given angle A, okay, and then side BC and side AB. Now keep in mind, this is side BC because it is between points B and point C, right? Or I would also call this side A. Side AB is between points A and B. I would also call it side C. And then this one that's not talked about over there is side B. So, I don't know. I kind of think better that way. It's all the same. So, we have our three possible options here. The first one, if your given angle is obtuse. Obtuse meaning larger than 90, or I guess I should technically say between 90 and 180, right? If your given angle is obtuse, there is one triangle possible as long as side A is bigger than side C. So if you have a big angle here, keep in mind, wherever the biggest angle is, the side opposite it should be the longest side. You remember that relationship in triangles? Largest side has the largest angle across from it. Shortest side has the shortest angle across from it. I should be saying that the other way around. But so, if you have your angle is obtuse and the side opposite is larger than the other, then one triangle is possible. If, however, the other way around. So if your largest angle is across from the side that's not the largest side, there ends up being no triangles possible. Okay, and again, I'm going to demonstrate these. Now, if A is acute, okay, so you've got two options here. If that given angle is acute, there could be two triangles or there could be one triangle. Okay, two triangles are possible if, I'm trying to think, side C is bigger than side A. So if angle A is acute and this other side over here is the longer side, there's going to be two triangles possible. One where angle C is the obtuse angle and one where angle C is an acute angle. Okay? Again, I'll demonstrate that later. And then if A is acute, there's one triangle possible in the situation where A is bigger than C. So there's a lot of ifs. And this is where my suggestion is going to be that we sketch a triangle on these. Look visually here and see what it looks like. So, example A. We'll at least get started on example A. Solve triangle ABC. Remember, solving the triangle means I'm just finding the missing pieces, right? So most of the time in this lesson, that's going to mean finding 3 pieces. So given that side A is 7, side B is 6, and angle A is 26.3 degrees. Now, I wonder if I could switch this up on the fly. I don't know if I can do that or not. I guess one thing before I continue here. Notice in this case, they mentioned angle A and angle C. Do those really have to be the names of our acute or obtuse angles? When they're talking about angle A is obtuse or acute, they're talking about the given angle. Okay, that's what they're talking about here. So, I'm going to draw me a triangle. As I look kind of at what the triangle, I feel like I drew that kind of small. I'm going to make that a little bit bigger. Okay, angle A was given as 26.3 degrees. I put it inside there at the left. Side A is going to be opposite that, and it is 7. And then side B is given as 6. Now, I chose to make B and C up there because they are similar in length. So that's kind of how I drew that triangle that way. Again, it doesn't really matter. Now, if I go ahead and label the other pieces, this is angle B because it's opposite B. This, of course, has to be C, and that, of course, has to be C. What setup are we given here? Is this truly where we're working? Okay, I have to check that, right? I have a side, and an angle. So this is a side-side angle. And what do you notice about that angle? The given angle is acute, isn't it? Okay. The given angle is acute. So at that point, we're looking at one of these two issues, or one of those two options. And as we look at that angle, notice the side opposite it is bigger than the other side. And so A is bigger than B. So this falls into this bottom run right here. A is acute, and side A is bigger than the other given side. So the given angle is acute, and its side is bigger than the other given side. We're just going to have one triangle option. Okay? That's what it comes down to here. What are we going to use to solve this? We're going to use law of sines. Based on what the information you're given, can you set up your law of sines? We're given the A information, and we're given side B. What must we find first? What?
Angle B.
Angle B. We have to start with finding angle B. So I'm going to set this up thinking sine of A over side A is equal to sine of B over side B. So fill in the given information. Sine of 26.3 degrees over 7 is equal to sine of angle B that I don't know yet, divided by 6. And I guess tomorrow we will have to talk about how to solve that. How do we actually find angle B? Remind me if I forget where to pick up.